So then I had started with this discussion, that annual worth method. This is where we left yesterday. And what I told you was that compared to the present worth method, the only advantage that annual worth, one is it's intuitive to understand, but the second important advantage is it makes your calculation a little bit easier, because you don't need to do it for multiple, you don't need to take LCMs and do the analysis for multiple cycles of each project alternatives. But the assumptions are still more or less same. Uh, Even though you're comparing only one cycles, you are ultimately making an assumption that subsequent cycles are all same, at least till the LCM. You will be repeating the analysis. In reality, that means that you are going to adopt those alternatives for the at least the LCM of the two lives. And in every life cycle, the cash flow remains the same. So these assumptions are still part of the game. And as long as your requirement satisfies these assumptions, this is a good method to use. Otherwise, you have to accept the results with a little bit of a caution, right? So let's do a calculation. I'm saying you that no LCM is needed in present worth, you need, but in annual you don't need. So let's do a calculation. Bring your calculator and everything, right? So this is the, for one cycle of, let's say, vendor A, right? So can you calculate the present worth of just one cycle of this cash flow series? Obviously this 15,000 won't come into the picture. Give me the present worth of just one cycle. So your cash flow is 15,000. This amount is what, 3,500. And at the end of 6th year, you're also having $1,000 in terms of the salvage value, but no 15,000 in that period. Can you give me the present worth of just one cycle? Oh, interest rate in this case was what? 15%. You have memorized the question. Yeah, it's 15% per year. $27,000.36. Option B. And if you have also calculated, give me present worth for option A for two cycles. 223.38. Everyone else, for one cycle, are you getting the correct answer? I don't know if it is correct. Are you getting the same answer or different answers? So 27,813 is the first cycle present worth, right? If you consider two cycles, in that case, this 15,000 will be gone. Rest everything remains same. What is the answer? Can you speak loudly? 27,678 is your answer for just one cycle. Let me make it a little bit more clearer to you guys. What I am asking you to calculate is simply what is this answer? 27,813 point something something. Okay, now give me the answer of this series. Give me the answer of this series. This is 0 to 12. 40,270. Is it correct? 39,837.84. Now is it correct? Perfect? Alright. So this becomes our answer, 39,837.84. Now give me the annual worth of vendor A for one series. So this is the series. Give me the annual worth, not the present worth. Seven three point 31. Yours is coming differently. 7348. It's okay. More or less in the same ballpark number. Everyone agrees? This is the number. Now calculate the annual worth of the second series. The second series is this one. Yeah. So it should be same. That's what he already told. But I'm the teacher, so I should be the one telling it. No, yeah. So that's essentially what my motive for just showing you this example was, that there is no need to take LCMs in the annual worth analysis. You see, in present worth, the moment you change the number of cycles, the present worth calculation is changing, right? The answer is different. These two options are different, and the more cycles you add, this number will keep on changing. But in annual worth, it is independent of how many number of cycles of like repetition of the same alternative you take. The annual worth will remain same. Can anyone tell me why? Why is this happening? Annual worth is coming same, present worth is different for two cycles. Why? No, of course you are adding two cycles. That's not the answer. Why do you think is happening? Is it a violation of your A by P formula? Of course, time value of money is like by default everyone. Can you show me some example? Why do you think it is happening intuitively? Uh-huh. So you are correct, but you need to show that when you are estimating the A, you are not bringing all those A values to the present worth. You are just reporting A in the subsequent time. So that's the factor it is affecting. It's not violating your A by P formula. It will still use you can still use everything the same way. It's just that the calculation becomes easier when you are comparing. So you don't need to take LCM, you don't need to do multiple analysis. You'll still get the same answer. You'll still get this, when you're comparing the alternatives, you will still get the right answer. It doesn't matter whether it is a present worth method or an annual worth method. As long as you're consistent, you will get the right answer. Okay. But this is with the situation when we are dealing only when there is a repetition of the cycles we are considering. If I give you a shorter time horizon and things like that, then you have to go by the normal method. You might have to check which method is making more sense or not making more sense. Okay, clear? Any question still? So is it easier? Annual worth? Understandable? Let me make it a little bit more complicated. So this again, I'm introducing this factor today here, but essentially we'll be using this a lot more in the later parts. But a generic form of representing this kind of an annual series is typically in this format. There is a P value, there is some amount of A value, and then there is a S value, which is the salvage value you get at the end of the investment, right? So P is the initial investment, S is the salvage value, and A is the annual amount. So then there is a term called capital recovery factor. Okay, this is very commonly used in the literature. We will see that when we do a lot of questions. So this is the equivalent annual amount that the asset, process or system, basically your alternative, must earn each year to recover the initial investment plus a stated rate of return. So essentially the A in this case, so the capital recovery factor you can calculate by this P into A by P, distributing this over the entire period, plus the S into A by F formula. The net sum of this is that at least that much money if you want to make, the capital recovery factor will give you the value, right? In this case, the I becomes your whatever your desired rate of interest is, or whatever you want your investment to make. So if I say that the initial cost of your investment is 10 lakh rupees and salvage value at the end of service life will be, let's say, 1 lakh rupee. So how much is the money that you need to make for 10% return? That annually, how much money you need to make for it to generate a 10% return, you can calculate using this kind of a capital recovery factor. right? It's essentially minus P distributed over the annual worth, the salvage value distributed over the annual worth. That much amount it should at least generate for the profit to be higher. Otherwise, it's a cost, right? Otherwise, it's a more sinking kind of a thing. Get the idea? This term, we will use it more later in some, towards the later half of the course, we'll be using it more frequently. But I just wanted to introduce because there is a question on it, which is also equal for our, like right now relevant for our problem solving. Okay, okay with the definition? Still a confusion? P, S distributed over the annual worth, the difference is the capital recovery factor, right? So let's look at the question. So SR company, which is a ready mix concrete supplier, wants to purchase and install 5 portable in-truck system for increasing delivery speed and accuracy, right? Each system costs about $4,600 and have a 5-year useful life. Each system can be salvaged for $300. The operating cost for all the system is $1,000 for the first year, increasing by 100 per year thereafter, right? MARR is 10%. Using the annual worth analysis, estimate how much annual net income is necessary to recover the investment at an MARR of 10% per year. How much annual net income is necessary to recover the MARR, whatever at 10% per year is given to you. So this is precisely the question of your sinking fund or capital recovery factor that I told you. There is a P value, there is a S value. You distribute this over the period, you distribute this over the your N A by F formula for I, and similarly that much money if your investment can make, at least you will generate more than 10% return, right? That's the question being asked. So this is classic definition of the capital recovery factor. Can you calculate? What is the P value here? 4,600. What is the formula? Correct? Or P by A? A by P, 10%, N plus what is the salvage value? 300. What's the answer? What's the answer? Minus 1164. Everyone, same answer? Minus 1164? Yeah. So essentially, what it means is, whatever the intermediate cash flow series is happening, the equivalent annual amount of that should be at least more than 11,164 for this entire series to make some profitable sense. If your whatever the intermediate cash flows are happening, if their annual equivalent is less than 1,164, this alternative is going to lose money. Making sense? So you see, in the net income, because question is net income. So I am, irrespective of what is actually happening, I am just calculating a theoretical value that you need in order for this particular business to make profit, right? That is the annual net income which is necessary. And that amount is coming out to be 1164. Apparently not. Am I wrong? Oh, there has to be a multiplication of 5 trucks. There was the question clear about it. Each system costs about $4,600. Okay, yeah, so you just multiply that value by 5. Hopefully you get the same answer. I'm hoping. So for the 5 trucks, this investment has to make at least $5,822 on an average for it to generate some profit at your 10% desired MARR. Clear? Okay. Now let's read at the second question. Second question is, now this SR company estimates an income of $6,000 per year for all the systems. Okay. Is this project financially viable at MARR is your question. So in the previous, net income that is needed is 5822. That's what you have estimated. That is the net income at least necessary. Now I have given you an information that this system is generating $6,000 per year, the whole 5 trucks together. Does this business make profitable, actually generate profit or no? Yes or no? Yes? Because I'm asking, that's why no. Exactly. So here we calculated the net income, and here I am giving you the total income, but there is a cost which is given to you in terms of a geometric series, right? An arithmetic, not geometric, the arithmetic progression series given. So you estimate the net of that, and then only you will be able to make a judgment whether it is actually at $6,000, whether actually you are generating profit or not, right? So now what's happening? With an annual income of 6,000, then the net income actual generated in net income series becomes $5,000, and with G is equals to minus $100. I've already taken, so 6,000 is your income, 1,000 is your base maintenance cost, which is increasing by $100 per year, right? So I'm, instead of taking 1A separate, all I'm saying is that my first base becomes $5,000 and the G becomes minus $100, right? This is clear. So now your annual worth of this particular investment at the 6,000 income would actually come out to be minus $1,000. So even at $6,000 income, you are actually not generating the profit in this particular business, because after combining everything, your net annual worth is coming out to be negative. Making sense? This analysis is making sense or not? Confused? Nobody is confused. Took me 2 months to realize this problem when I was doing the first time, like what is happening? I had a lot of time in the beginning when I had joined. So, clear? In the first question, we estimated the net income that is ideally necessary for it to make the profit. Now I have given you the actual income level. In order to calculate the net income from actual income, you need to subtract the cost, the actual maintenance cost that you've gotten. And then we have compared that even after that 6,000 level, am I making profit? I am saying I am not making profit. This is the answer for this case. Another variation of the same question could be, how much should be this income, annual income, for you to actually generate profit, right? You can easily estimate. Basically, you are making the equation balanced and you can easily estimate the A value corresponding to that, right? Clear? How the capital recovery factor has been used. Alright, let's also compare another alternative, because this is more on the long service life question. I told you that I will come up with this question slightly later, precisely because this capitalized costs involve the A, like annual worth estimation. So I thought I'll take the questions later. So let's say in this what happens is, the Indian Bureau of Reclamation is considering 3 proposals. 5% is your interest rate for increasing the capacity of the main canal in an agricultural region, right? So proposal A requires purchasing of a dredging equipment which is 650,000. The service life of the dredging equipment is 10 years. In canal, dredging equipment is basically removing the weeds and everything so that the actual canal surface is well maintained. It's dredging is also to remove the sediments that get deposited at the bottom, right? So the dredging equipment is 10 years and the salvage value is $17,000. Annual operating cost of the equipment is $50,000. Further, to control the weed growth, the yearly cost of weed control program is $120,000. So this is your option A. Option B is to line the canal with concrete at an initial cost of $4 million. So in the first one, you are just removing the sedimentation so that the flow of the river is maintained or the canal is maintained. In the second, you are making it a concrete lining. So that's slightly more expensive. The lining is assumed to be permanent, right? So there is no end of life for this. but minor maintenance is expected at $5,000 per year. And in addition, lining repairs of 30,000 will be required for every 5 years, right? And then proposal C is to construct a new pipeline with an initial cost of 6 million, annual maintenance cost of $3,000 and a right of way of 50 years. 3 options to transfer water. One is do nothing but maintaining through the equipments. Second is to maintain a concrete lining, and basically that is more permanent solution. And third is to make a pipeline, but pipeline does not actually require the land, so you are leasing the land for 50 years. So after 50 years you can still make a choice whether this project is needed or not needed, right? These are the 3 options. We need to find which one is the better alternative using the annual worth analysis. Okay. So here is your answer. So since the investment of a permanent project, you have to compute why again because see in the original capitalized cost kind of a scenario, I told you that you need to take at least 2 cycles and all. In annual worth, that problem goes away because no matter what, you are actually considered only about a single cycle of the investment cycle. So you don't need to worry about that. So here the proposal A, your capital recovery factor for dredging equipment is what? 6,50,000. A by P, 5%, 10 years. 10 years is the life of the dredging equipment, right? 17,000 is its salvage value. A by F, 5%, 10 year. So you have gotten the effective annual cost required for this particular equipment to be there for 10 years, right? Annual cost of dredging is, it's already given to you, $50,000. Annual cost of weed control is given to you be $120,000. So the total annual cost for option A would be sum of these 3, right? Making sense? Proposal B, your initial investment is what? 4 million. You need to calculate the present worth. I am telling you n is infinity. So instead of using the formula of A by P, what you just do is simply multiply P into I, right? I is 5%. So this comes out to be minus $200,000. Your annual maintenance cost is given to be what? For proposal B is given to be $5,000. And then every 5 years you have a additional maintenance requirement. So thus that 30,000 A by F 5% 5 you get additional, and therefore you have considered the whole one cycle at least of the entire analysis, right? So the total here comes out to be $210,000. Now proposal C, construct a new pipeline with 6 million, annual maintenance 3, right of way of 50 years. So here you are taking this 6 million, you are distributing that equivalent A value till 50 years using A by P formula. You get this answer. Annual maintenance cost of another $3,000. The total comes out to be $331,680. Making sense? How the long capitalized cost formula is also sometimes useful to make your life simpler. But again, instead of doing this here, you could have actually applied it to a theoretically very large number. Even if you take 50, the error of margin would not be very high. You will still get somewhere around, if not 200,000, maybe slightly higher than that, right? So again, you can also make a judgment in terms of whether you really need a simple formula or you do want to take some theoretically random high value, right? Now with Excel, you have no limitations in terms of what could be the largest N for which you can calculate. It's pretty simple, right? Making sense so far? Annual worth analysis makes your life a little bit easier because of only calculating for just one life cycle, right? That's the good part about this particular method. So in this, of course, the lowest cost. So proposal B is the winner. With me? So far, everyone all clear? So we have covered 2 project alternative methods, and then finally there is something called a future worth method. Nothing significant. Once you have known the annual worth or the present worth, if you want to calculate the future worth, instead of doing it in the prior, you can actually take the time comparison with the last. So there is nothing new here. Works exactly same as the A. Works exactly same as the P. Instead of P, you need to use the formula of F. Answer will remain same. from present worth, annual worth and future worth, your answer won't change. Doesn't matter what method you use. In present worth, the time horizon, if you are changing, your answers may change. But for the same time horizon and same n value, all three methods would be giving you the same answer. Okay? Alright. So, now let's switch gears to another important concept. Have you guys heard the term IRR? How many of you know what IRR is? So, see, so far what I had given to you, I had given you a MARR, which was my expectation rate of return, right? But can I have an absolute measure? This is depending upon if I want 8%, 10%, 12%, my present worth is keep on changing, right? So I am confused. Could there be an absolute way to define that this investment will on an average generate this much rate of return? MARR is supplied by me. MARR is that minimum this much I want, and that at that rate I am comparing. But could there be an absolute value of a rate of return of an investment considering the time value of money is the question, right? For example, in the beginning when I gave you the payback period and all, we calculate IRR by what? The final amount divided by the initial amount as a percentage, right? So I think in the example we covered some 50% return was coming. That is not MARR, right? That's only the investment's property. It's the property of the investment. It's the property of the cash flow series. Independent of whether you like it or not, this investment will generate this much rate of return to you. That's the meaning of IRR. Okay. So in all the calculations we have done so far, I had given you the discount rate. In this case, I am asking you to estimate the rate of return for the investment will generate. So it's a slightly different angle to the problem. Earlier the R was known, the rate of interest was known. Here you have to estimate it using some sort of a formula that we will look at it. So a lot of people use this, especially when for example, comparing typical loans, right? When you have to compare the alternatives of which bank to go for loan, immediately you see that, okay, this bank is giving me 8.25%, this is giving me 8.45%, this is giving me 8.95%. Okay, I will choose. It's a method for you to make a decision. Similarly, when you are doing, for example, fixed deposit investments, each company offers you slightly different rate of return. So you can determine that, because in that case, your cash flow is determined by you. Originally, your rate of return was something that you determined. Now your cash flow, you know that on an average, I will invest 10,000 every month. I want to maximize my return on it. So I will go with the highest rate of return. And that's the concept of IRR. Okay. Let's look at into more detail, but this is a commonly used measure for economic worth of a project, and it's also known as internal rate of return called IRR. Okay. So the technical definition of IRR, this is an interest rate at which the present worth or the annual worth of the cash flow series will be exactly equal to 0. So if I want you to estimate the IRR of an investment, what I will do, you will estimate the present worth as a function of I and N. You can do that for any cash flow series now. You just equate to 0 for the given N. So you know you can estimate the value of I. That value of I is called IRR, technically. Okay. Otherwise, AW, which is the annual worth, you equate that to 0 and you get the I value. Of course, it has to be a net cash flow series, a positive and negative. Can you calculate IRR for cost only projects? Why not? It will never be 0 because cost only negative, so it will ever be minus. It will, no matter what you choose, I or N, you will never be able to make it 0. So IRR is only applicable for where both the revenues and the costs are involved, right? So of course this method is limited. You cannot use it for cost only projects directly. But there's a trick question which I'll ask you later. Just to make your life little bit more complicated, I'm using the notation as the I star so that you don't confuse between I and I star. I know you, by introducing another, you are getting confused, but I warned you, right? Now, the acceptance criteria. Let's say you want to make a judgment. Absolute value of IRR does not make any sense. If I say it's a 5% versus a 10% versus 20%, of course, one project is better than the other, but then you can't make selection of just the 5% because you are dealing with the mutually exclusive argument, right? That's the kind of idea that you are dealing with. So, your criteria is that if your IRR which you have estimated is at least greater than equal to your minimum acceptable rate of return, only then this project makes sense for you. Otherwise, it's better that you do not invest the money in this project. That money is already getting invested somewhere and it's generating you at least MARR. So, only when your rate of return, the IRR of a project is more than your minimum acceptable rate of return, only then it makes sense for you to invest in a particular project. Right? Making sense? So, in a slight twist to the language, in all previous problem, your discount rate was known. Here, we are calculating the discount rate at which my investment becomes profitable and things like that, right? So, the idea is that you equate these terms to 0 and you can estimate the I percentage. Sounds easy? What is the problem can you foresee right now in estimating I? You must do it what? Iteration wise. Why? No, but you can solve for I through normal equations. What's the problem? Yeah, so it's that's a higher order equations. If your n is like 50, you are solving possible 50 solutions of the problem. That's where it becomes trickier, right? Because of the n order polynomial, the function is an n order polynomial. Therefore, it's not an easy to start the answer. So, therefore, mathematically simpler is the guess estimate. You start with some estimation, you move around and see where the IRR series is heading. Based on that, you can estimate. If you know the IRR between 2-3 points and one is below 0, one is above 0, you know that somewhere middle has to be 0 and that's how you can linearly interpolate and get the answers. We'll look at the examples, right? So, first is of course trial and error method. So, idea is you draw a cash flow diagram, you set up the rate of equation in terms of, you estimate the PW in terms of I and N, assuming whatever value of I, you equate it to 0, select a value of I by trial and error until the equation is balanced. I will show you the example, but it has to be done trial by basically trial and error method. You can also use Excel sheet. Excel sheet also does a trial and error. There is no way for it to solve such high order polynomials so easily. It also does a trial and error, and I'll show you if it is, this sheet is openable. I'll send you this sheet, remind me, I will share, but in that example you will be able to see this is a particular formula that you use. You put IRR and you just input the cash flow series from whatever the number, first cell of cash flow series versus the last cell of the cash flow series in this column, and then you, in the comma, the another argument is a guess. The initial start, whether 5%, 10%, 50%, whatever value you are putting, you can give Excel also a start so that it converges faster. Sometimes because of your start, the Excel goes like crazy. It actually does not guarantee, this formula does not guarantee that IRR will always be calculated because it's a tricky function. We will look into it a little bit today also, right? But there is a method. Okay. So, let's see how the IRR calculation happens by trial and error. A generic IRR profile or an NPV profile looks like this. There is some sort of a decline. So, what you can, one easy way to do is, in Excel you put NPV as a function of I and N, and then across different cells of Excel sheet, for each value of I, you can calculate the NPV values, plot that. Wherever this term is wherever the graph crosses the axis, right, that's your IRR, because this is where NPV becomes 0. So this becomes your IRR value. Similarly, for this particular investment, IRR value is somewhere here. So that's called a graphical way to estimate IRR. Is it making sense? Not making sense? This is a generic, most generic profile that you will get at least in this course, but not in real life. I'll show you how. But essentially in this course, you will get simpler cases where this kind of a generic profile will hold true. And in that case, graphically, all you need to do is read the value of I at which the NPV becomes 0, right? Similar concept using trial and error. How can you do? You first start with some random assumption. All right. You counting the cost as negative and income as positive. You find the equivalent present worth at this particular assumed I value. Let's say you started with I as 5%. You calculated all the cost as negative and the income as positive, and you estimated the net value, right? If the equivalent net worth is positive, then the income from the investment is worth more than the cost, right? If at this assumed I value, if your income is higher than the cost, it means the actual rate of return should be slightly higher, right? Because at this discount rate, you are getting actually a positive side of the curve. So the actual percentage return is higher than the trial rate and vice versa. If at a assumed value, you are getting less or a negative, it means your actual return is slightly lesser compared to what you have assumed. As you can also see in this profile here, if I, let's say, originally assumed, I am talking about the curve in the dark brown or black color, whatever it is. If I originally assume, let's say, I to be 10%, my value is coming out to be here, which is a positive value. So I move towards slightly higher values and I start seeing that this curve actually goes down and somewhere around 20% it becomes 0. If I had originally started from higher value, it is coming out to be negative. It means the actual discount rate or where the profit will become 0 is slightly lesser. So you start moving back, right? Get the idea of trial and error? So, and then you need to adjust the estimate of trial rate of return. Go to the step 2 again, such that you need to do this kind of analysis such that you have found at least 2 values of NPV which are either side of 0. At least one NPV which is positive and at least one NPV which is negative. Then the solution must lie in between the two, and that you can estimate using the linear interpolation. Right? Making sense? So let's look at an example. This is the cash flow series. You have 100 plus 20, 30, 20, 40, 40. Some I value we don't know. So this is the kind of cash flow series you have plotted, right? So you convert this into a present worth format. 100, 20 into P by F, I for 1 year, 30 P by F, I for 2 year, 20 P by F, I for 3 year, 40 P by F, I for 4 year, and so on and so forth, right? You assume I to be 10%. You calculate at 10%, you can estimate this expression. This comes out to be 10.16 positive. So it means the actual I will be slightly higher than 10%. So next trial you assume it to be 15%. You calculate the value is coming out to be minus 4.02%. It means that there is at least one solution between 10% and 15% that you can estimate by linear interpolation. So graphical way is quite powerful if you are not clear what exactly IRR is, and sometimes especially in Excel sheet your formulas will give you error. It may not be even computing the IRR value, it will simply give you an error message. In that case, plot the profile and look at that NPV versus I value you can plot, and then you can estimate at which it is crossing the horizontal axis. Now I'll just leave you here. So in general, as I told, we will be dealing with simpler graphs like this. But real world IRR are very complicated. They can have random shapes. And in that case, your assumptions will not hold true. Even your trial and error methods will not hold true. For example, this is a degree polynomial. So in this part of the curve and in this part of the curve, your trial and error method works differently. Here it's the normal case. Suppose originally you had assumed 70%. you are getting a positive value. So you go higher side, you get around 195%, you get a negative value. In between, you found an answer. This is what we have seen. But in this part of the curve, the reverse is true. So you actually don't know what curve is real world it is following. So it's always better to do the graphical way so that you know how many points the curve is intersecting, and then you can make a judgment accordingly. For your calculation purposes, I will give you simpler cases where this trial and error method holds true, but actual IRR is much complicated, and you can imagine it's an n order polynomial. It can have n roots, so it can cross many times, and therefore there can be multiple solutions to the equation, right? Typically this problem happens when there is a very large negative cash flow in a particular series. So suppose you are having some positive cash flow with an initial P, suddenly a very large maintenance is required. That kind of disturbs the real IRR cash flow series very much, and then you will have multiple routes possible and things like that. Okay, we will not be dealing, but your infrastructure projects, this problem exists. Sometimes they require maintenance after 30 years, major maintenance after 30 years, 40 years, and in those conditions, this can create a problem for you. Okay.